Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 8.4. 8.4 is looking at angle relationships in circles, similar to 8.3 where we're looking at segment relationships in circles. So depending on which lines are drawn through our circle, whether they are chords, whether they are secants, whether they are tangents, we're going to end up with a few angle relationships. More or less, this is just a formula that you need to have down, and if you're taking good notes and this is in your notes, then regardless of the circle problem that you are faced with, it should be pretty straightforward, hopefully. Just like last time, I went ahead and sketched these ahead of time, just so to save ourselves a little bit of time here. So there are three types of angles we're going to be looking at in terms of the circles. There are angles that are on a circle, there are angles that are in the circle, and there are angles that are outside the circle. So based on the diagram, we are going to be solving for a given measurement, is essentially what's happening here. So just like before, throughout Unit 8, my letters that I'm just putting here may be a little bit different than those in the PowerPoint. They may be a little bit different than those in the textbook, but we're just using them to reference the angles. Okay? So let's call this first angle ABC. Our first relationship, if I have two chords that intersect at a point on the circle, so basically I have an angle that's contained inside. Now this is different than a central angle, right? Central angle is an angle that goes through the center of the circle. This, the vertex, is on the circle itself. The relationship that we find is that the measure of that angle is half the measure of the arc length that it is intersecting. So the measure of the angle is half the measure of the arc length that it is intersecting. So on a question, if I give you the measure of an angle here, I could ask you for the measure of the arc length. If the measure of ABC is 50 degrees, then the measure of arc length AC would be 100 degrees. That's the idea. And I could go the other way. If I give you the measure of the arc length as being 120 degrees, then you would tell me half of that, the measure of the angle, is 60 degrees. That's the relationship you need to understand. This is for angles that are on the circle. Going the other way, if I have an angle inside the circle, let's say I want to find this angle, and again, we're just making up letters here, D, call the center O, E, F, G. What we find is that when we have two angles or two chords intersecting, the vertical angles, such as EOF, okay, is equal to the average of the intersecting arcs. So it would be half of whatever the measure of arc G is, and the measure of EF is. It's half of that average. So same thing, if I give you 2, you should be able to find the third one, regardless of which one I give you. So I can tell you the measure of arc length DG is 60 degrees. The measure of EF is 100 degrees. And I could ask you to find the measure of angle EOF. In doing so, you would use your formula. So I'm taking the average of the measure of DG, which is 60 degrees, plus the measure of EF, which is 100 degrees. 100 plus 60 is 160. Half of that gives me 80 degrees, like so. So those are the first two. From here, our last one that we're going to do is angles that are outside of the circle. So to find angles that are outside of the circle, we are going to use yet another formula. First, we're going to assign some letters here. So let's say I have, we'll call this point O. We'll call this A, B, C. And to distinguish between here, that's fine. So the measure of the angle that is outside of the circle is going to be not the average, but half of the difference. So the measure of angle AOC is equal to half of the measure of the larger arc that it's intersecting, which would be AB, minus the measure of the smaller arc it's intersecting, which would be AC here. So it's the average, not the average, but it's half of the difference, not half of the sum. So same thing, if I give you 2, you should be able to tell me 3. Say the measure of arc length AB, and not angle here, but arc rather. Measure of arc AB is, let's say, 150 degrees. Say the measure of AC.
Oh wait, can you even hear me?
Is 80 degrees. So if I ask you to find the measure of angle AOC, that is half of the difference, 150 minus 80.
Doctor?
Half of 70 gives me 35 degrees. So pay attention to what's given to you. Be careful. It's very easy to get these formulas confused, but after you do it a while, and if you have the notes up, you should be able to figure out which is which. But that's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.